Good morning, geometry students. I hope you're having a good day. It sure is beautiful out. I think it's supposed to get rainy later, but that's beside the point. We're ready to do geometry, whatever your setting is today. Now, I did get a couple of questions yesterday from a couple of you. One of you had asked for something else that is in the real world category, and somebody else had asked for finding a price for the cubic feet type of a problem. So I don't have a cubic feet type of a problem, but I do have a cubic centimeter type of a problem that I've added on at the end of this lesson that applies to today's formulas. So what we're going to do is we're going to go through some of the formulas. Now, it is a great idea for you to be making a list of the formulas so that you've just got them right there in front of you. That's always kind of a good strategy for chapters, is to make sure that you've got your formulas ready so that you're not constantly paging back and forth for formulas. So we have on this one, we're going to start off with surface areas for spheres, and then we're going to talk about volumes for spheres. Now, we know a sphere is really just a ball, okay, a perfectly shaped ball. And so when we think about surface area, you would be thinking about possibly like if you had a baseball and you needed to put that leather cover over the baseball, how much leather that you would need to cover over that baseball. Or if you were thinking about even like you were making a piñata out of a perfectly round balloon. That's kind of fun, actually. And you wanted to find out the surface area of that, so you'd have an idea of how much glue and paper that you would need to make that piñata. So surface area of the surface, how many square inches it would take to actually cover that surface. So hopefully those couple of examples made it clear as far as what a surface area would be. When you think about the globe, the world map, and then sometimes you see that it's been like cut out, and there are some versions of it that's where if you would cut it out and made it flat, that would be the surface area type of an idea also. So our formula for that is 4 pi r squared. Sounds very, very similar to our area of a circle formula, except for it involves multiplying by 4. And that is really just how it works out as far as how that formula presents itself. And so we're just going to do an example of using it. And then we'll talk about the volume of a sphere and go on from there to that practical problem that I promised you. Okay, so let's go to that baseball question. The baseball has a radius of 1.43 inches. How much leather is needed to make the baseball? In other words, to cover over the outside of the baseball. You have that center core, whatever that is, but you need to make the leather on the outside, so you need to know how much would be needed for that. So we'll use our surface area formula, 4 pi r squared. The radius from the center of the baseball out to the edge of the baseball, 1.43 inches, so you would plug in your 1.43. You can use any calculator that you want. I'm going to use this one. 4 pi times 1.43 squared. Okay, and what we end up with is about 25.7 inches squared. Now this is square inches, it's not a volume, it's a square unit. Now I have this calculator here, and the directions on the website as far as how to download this particular version seem to not necessarily work with everybody's operating system anymore. I did talk about WabbitEmu for the Android phones as far as working. Texas Instruments is doing a thing where you can get a 90-day free trial of the TI-84, and they don't make you put in your financial information or anything for that. And I did put a link on the website at the bottom of this week's instructions if you're looking for a simulated calculator to use. The 84 Plus works just pretty much identically to this, but that's a resource for you if you are so inclined for that. So check out the website. If you scroll down to the bottom of this week's instructions, there's a link there for that. Okay, like moving right along. All right, volume of a sphere. Volume of the sphere, okay, the volume, we're using the same baseball as an example. However, if we think about other things that might have a volume, if you wanted to make a snowball and you wanted to know how much volume was in that snowball, or if you wanted to have a blob of ice cream that was a circular blob of ice cream, and we'll get to that later, and you wanted to find out how many square inches or how many square centimeters of whatever that was, I mean not square, cubic, because volume is in cubic units, how many cubic units were jammed into there as far as volume goes. So volume is different than surface area. Surface area would be like if you're trying to cover over the outside of it. Volume is really how much stuff is packed into it. If you think about your definition of matter from science, it's anything that has mass and takes up space. Another way to say takes up space is that it has volume. Okay, volume can be measured in our cubic units, as we know, or it can be measured in milliliters or liters as well. There's a couple, volume's a very special type of quantity. But in order to get a handle of what this really is, we're thinking about like if you had to pack the stuff into the baseball, the interior portion of it, what would be the volume of that material? Okay, so volume, 4/3 pi r cubed. 4/3 pi r cubed turns out to be that formula. R cubed, if you remember, that almost sounds like the area of a cube formula, and it is. But because we've got a circular thing working with us, pi gets involved, and it does come out to be 4/3 of that amount. So we're going to take a look, same baseball. Okay, 4/3 pi r cubed, 1.43. Now we know that cubed means 1.43 times 1.43 times 1.43. So if you were doing it out by hand or with another calculator, you would do that. The safest way when you're using this calculator to enter in a fraction is to go ahead and put the fraction into parentheses. Divided by gives you your slash for 4/3. I say the safest way because there's a lot of things that we look at something like this and it's very easy for us to mess up our order of operations. The calculators use the order of operations strictly and exactly. So you want to make sure that you're telling the calculator what you really mean for it to do. So if I want this fraction to be 4/3, I want to make sure that it looks like the fraction 4/3. And then I want to multiply that times pi. That's the second of the caret. If I want the actual value for pi. Then I want to multiply that times 1.43 cubed. 1.43 cubed. In order to do that, there's no cube button, but this up arrow makes an exponent to the third power. Now, if you do have an 84 plus calculator, it does the service of raising it up so you can see what you did with that. But just so you know, in this calculator, this is what this would look like. This is the one that I had told you to buy at the beginning of the year, so I want to make sure I give proper instruction on that. And then we get all in one calculation, 12.2 about. or 12.24. Now if you'll notice here, I have an extra step put in because you could do this by steps if you wanted. Okay. If I wanted to, I could take 1.43 cubed all by itself. The caret. And that's where this number comes from. For those of you that don't like to use the cube thing and you want to do it in even more steps, you could do 1.43 times 1.43 times 1.43. If you don't have this type of calculator, get this number. Then multiply by 4/3, and 3.14 would be your approximate for pi, as you know. But here's where your answer comes in. 12.24. Notice that if I was doing strictly rounding, if I used this calculator and didn't do the sub step, I would be at 12.25. But if I used this, and if I used 3.14, it might round a little bit differently. So just please use the rules of rounding on the number that you get. But if you rounded one of your steps, you might be slightly off in them. I've been nice about making sure to take into account you may have rounded in different steps. So just make sure you use the rules of rounding on whatever number you get. If I did it strictly out in one step in the calculator, it would be 12.25. Okay, whatever step I used when I made this slide, it rounded to 12.24. That's only a difference in the hundreds place. If we rounded to the tenths, we'd all have gotten 12.2 and everything would be fine. All right, so there's that. Okay, let's look at this practical problem that I talked about earlier. We're going to use a couple of ideas here. We're going to think about an ice cream cone. Okay, and in this ice cream cone, we're going to ask how many cubic centimeters of ice cream is in the ice cream cone if the cone itself, now this bottom part is the cone, is 12 centimeters high, and the circumference of the cone, okay, if you think about the ice cream blob that's sitting on the top, the circumference of the cone is 18 centimeters. And this particular ice cream store is very, very meticulous about making it go like that. Sometimes you get them packaged like that when you buy them at the store in the big packages, or you get them from the truck that goes down the street. Sometimes when they're pre-packaged, you have a very, very specific volume that has been put into that cone. So we want to put into the picture these different measurements so that you can keep track of them. Okay, so all I did here is I made it look more like a cone, more like a cone with a sphere sitting on top, or a half sphere sitting on top, and labeled a couple of things to keep track of. So when we label those couple things to keep track of, we've got our 12 centimeter height this way, and we got our circumference of 18 centimeters this way. And so we want to think about how much ice cream is actually in the cone, and we're going to count the actual cone itself as being negligible, and figure that you can get ice cream completely shoved down into the bottom here. I know when I make an ice cream cone, I put the ice cream all the way in because I want the maximum ice cream. So, and it tastes really good when you get to that last bite. And I'm not sure if you're in that same boat with me, but I like the last bite that's got the ice cream jammed down into the bottom, a little mushy. Anyway, the ice cream in the cone, we need to calculate how much is in the cone and then how much is in the blob on top. So in our cone formula for our volume of the cone, if you remember, it was 1/3 area of the base times the height. We have the height that's 12 centimeters, but our area of the base, that is pi r squared, because it's a circle that's at the top of the ice cream cone. So we need, before we can go further with this problem, we need a radius. We're given a circumference. So you have to think about the formulas that you have and what makes sense. You know the formula for a circumference can give you a radius because circumference is 2 pi r. So in order to solve this, you need to take your circumference, which is 18, and divide it by 2 pi. All right, now once again, we have to be very careful to tell our calculator what to do. We need to take 18 divided by, and we want to put parentheses around the 2 pi. Remember I said that it does exactly what you tell it, and it will use the order of operations. The parentheses are needed so that it will do this first. Remember in PEMDAS, parentheses, then exponents, none of those, multiplication and division in order from left to right. So without these parentheses, the calculator would have divided by 2 and then multiplied the whole thing by pi. So please be careful with that. So 2.8647, so about 2.86 is our radius. Okay. So we're going to use that radius to put into your area of your base formula, pi r squared. We calculate that. Once again, we'll calculate that on your calculator. We have pi times 2.86 squared. So about 25.7. And so 25.7 would be our area of our base. We're still trying to calculate the volume of ice cream in the cone, so we need to use this b that we got and put in our h, 1/3 area of the base times the 12 that's the height. We've got a fraction to put in the calculator, so we'll be careful with it. We want 1/3 times 25.7 times 12. So 102.8 cubic centimeters. 102.8. I can bring this back. So that's the amount of ice cream that's actually jammed in this cone, and then you put a blob on top, because an ice cream cone is pretty lame if you just fill it up to the top. So on top we've got this blob. This blob is actually, it's spherical, but we're not counting the bottom part of the sphere. So if I can figure out the whole volume of the sphere and then cut that in half, that's how much this blob on top is going to be. So we need to use our 4/3 pi r cubed formula for the volume of, if you're thinking about the entire sphere. So we would figure out how much that is. That's going to be about 98. Once again, being careful with the calculator steps. 4/3 times pi times 2.86 cubed. Remember, caret to the third power. Taking so much time because this is newer to you than anybody else. 98 cubic centimeters for that. So we have 98 for the total. Need to divide it by 2. Remember why? We're dividing it by 2 because we're not talking about the whole sphere here. We're talking about just half of it, which is the blob of ice cream on top. So the volume of the ice cream is the ice cream that's jammed into the cone plus the ice cream on the sphere that comes out. So 152 cubic centimeters of ice cream. Now, as I said, one of you had asked for, okay, this is the practical one, sort of. Okay. And if you were an ice cream company and you were trying to figure out profits, you'd want to be able to figure out things like this. But then let's think about the cost. Okay, let's say you go there and for whatever reason the ice cream store that you're going to is going to charge you by the cubic centimeter of ice cream. So for a double dip, instead of having that single 49 cubic centimeters, if you put a second blob on top, you would add another 49 and then maybe a third. You could have a triple dip. And if they charged by the cubic centimeter, we could figure out the cost of the ice cream cone if we know a little bit about what their parameters are as far as how they're going to charge you. So I made up this problem so that we could do another cost problem. So the cone itself, you've got the outside cone, so they're charging 25 cents for that. Okay, that's not volume specific at all. That's actually more surface area, if we're honest about that. So, but we're not figuring that out. They're just saying they've got a flat out cost. You've got 25 cents for the cone and 2 cents per cubic centimeter for the ice cream that goes in it. So when you know how much ice cream there is and you know how much it is per cubic centimeter, this is just like your per cubic foot or per cubic meter that we talked about before, we have to multiply this times 0.02. You're multiplying it times the cost per cubic centimeter. So 304. You could use a calculator if you want. So $3.04 for the ice cream part, taking into account that they also are having a cost for the cone part. So we would be spending $3.29 for that ice cream cone. All right, I said the thing about the double dip, okay? We're adding another half sphere. How about half sphere? So let's add to this problem just a little bit. Let's say you wanted a double dip. So the double dip is going to add another 49 cubic centimeters. 49 cubic centimeters is going to add 49 cubic centimeters times 2 cents. Which will give you 98 cents. So for the double dip, we would add 98 cents on that. So $4.27 for your double dip ice cream, and so on and so on. For every dip of ice cream, you would end up having another 98 cents put on there. And honestly, that first ice cream cone did look a little lame. You'd probably want the double dip. But you could use costs like this. It's actually, depending on the ice cream place, is maybe kind of average. But here we go. So there's a cost problem. I actually really like this problem. To add on to help that person understand that had asked the question about finding price. And then this is also runs along the line of something that's a real world type of a problem that might be helpful to somebody who asked that question. All right, so there is that. I want you to make sure that you're doing a fantastic job with figuring out your work today, surface areas of volumes and spheres. Make sure you fill out the form afterwards and give your feedback and ask your questions so that I can include whatever you might need in tomorrow's and make sure that we are completely ready for your quiz on Friday. All right. Have a fantastic, wonderful, blessed day, and I will see you when I see you.